Number 52. Measuring devices determine the precision of our scientific measurements. A graduated cylinder is used that has a maximum of 10 cc's, but has 10 increments in between each whole number of cc's. Which answer is a correct representation of a volume measurement with this cylinder? Well, before we look at those questions, I want to show you what they're talking about here, a graduated cylinder. I just went to the internet and pulled a picture, and I'll zoom in here so you can see it. This is a graduated cylinder, and it measures up to 10 milliliters. That's what they were saying. It has a maximum of 10 cc's. A milliliter is the same as a cc. So it measures maximally 10 milliliters or 10 cc's. And here's an even closer version of that. So within this 10 milliliter range, you have smaller increments in there. So what this is saying to us is that this is measured in tenths. Each of these on the graduated cylinder, it goes up to 10. So each one of these sections is 1/10. In other words, I can't do it small enough. This is a tenth. This is a tenth. This is a tenth. Each of those bigger sections is a tenth. So if we cut each of those 10 ways, what would be the next increment that we would get? Another way to think of it is that you have 10 cc units or milliliter units that are each divided into 10. So 10 times 10 gives me 100 of those small units on the graduated cylinder. And those are going to help me answer this question. Which one of these answer choices is measured in hundredths? And that, of course, would be this one. The tenths are definitely shown there. You would have a tenth of a cc. You could have 7 whole cc's. All of those could be shown. D could not be shown because it doesn't go to the thousandths place. But you could measure hundredths in this cylinder. This question is a little bit odd to me. I'm not sure what they're getting at, and maybe I'm not explaining it as well as I should be, but the answer here is C, 7.15 cc's. That's a very precise measurement. But when you think about dosing medicines and things that are potentially harmful to people, it's really important to be precise and to know how to read those. You see if I can zoom back in here and get rid of this, and we'll try to mark that location off here. So 7.15. I can't really do it here. Here is 7, this line right there, and I'm zoomed in so much that I can't even write that small. So this would be an even 7 milliliters, or you could say 7.0 cc's. That still is not a lot at all. If you look at the quantity, imagine filling that with water. That's not a lot of water at all. We're talking about very, very small units and very, very precise measurement. So the 7.15 would not even be to that first line there. That first next line is 7.2. So you're talking about a measurement somewhere in, I can't even get that small, in this area right there, 7.15. It's a very precise measurement.